In this video, we're going to learn how to implement a queue from scratch. So first, a little tip for pronouncing this word. So first, you get rid of all the vowels and then you can pronounce it. Implementing a queue from scratch. That's how you pronounce it. Then you add the vowels back and you have your word. Okay, so let's first see what a stack is. So because we will need stacks in order to implement our queue. A stack is a data type that implements LIFO, last in, first out. The stack has methods push and pop. So, as shown in this image, you push an element, in this case 1, you can push another element, in this case 2, and when you pop an element, then you get rid of the last element you pushed, in this case 2. So that's what this paragraph is saying. Push adds an element at the end of the stack and pop picks up an element at the end of the stack. In Python, lists are stacks, but push is not called push, it's called append. And pop, well, it is called pop for lists. There is another data type called queue that implements FIFO. That means first in, first out. The queue also has methods push and pop, although many people call them enqueue for push and dequeue for pop. Push adds an element at the end of the queue, and pop extracts the element from the beginning of the queue. So that's what this image is telling us. So if you want to enqueue or push, an element, then you add it at the end of the queue. And if you want to pop or dequeue some element, then you take it out from the beginning of the queue. Okay, so then you are saying, well, we can use the method pop and for lists, and the method pop accepts an index. So let's see this in action. So we have, for example, this list. Let's create a list with 10 million elements. Okay, so you can append some element, and let's time it with this time. And let's see, let's add this element 50. It takes like 5 microseconds. Now let's try to pop an element, and remember, if we are in a list which is a stack, and pop is going to remove the last element from the stack. So it takes like 8 microseconds, very fast. The last element was 50, so pop returns the last element from the stack, which in this case is 50. Now let's pop the first element and time it. So we pass the index 0, and as you can see here, it takes about 10 microseconds. So you may say, but it's microseconds, it's still fast. Yeah, but it's like 3 orders of magnitudes slower in order to do this operation for lists. So as you can see here, using pop 0 works over a linear time. So that means that you have to traverse all the list from the end to the beginning in order to find that element and take it out from the list. And that is very slow. That works over a linear time. That means time complexity ON, for those of you who know time complexity. And push and pop, as you saw, it's very fast because that work over time complexity O1. So this is like the fastest thing for algorithms, and this is very, very fast. It takes like, this is saying it takes 1 unit of time in order to do this operation. So it's very fast if you pop the last element or if you push an element to the end of the stack. So our naive approach of using this pop 0 is not working that well. So let's implement our own class queue that is going to do the work that should do. Okay, so let's put here the not so naive approach. And I'm saying not so naive because our solution won't be perfect, and you will see why. Let's implement our class Q, and let's create this constructor that is going to accept one parameter, which is going to be the initial list. Here we're going to create two lists. The first one will be called the push stack, and we're going to initialize it with the initial list. The other one is going to be the pop stack, and it's going to be an empty list. Okay, so now we can define our method push, or append if you want to call it like that, and it will receive an element, and we'll simply do this. Push stack, we're going to append this element in push stack. Okay, now comes the tricky part. We're going to define the pop method. It won't receive any parameters, and we're going to say the following: if not self pop stack, so if pop stack is empty, then not self pop stack is going to be true. So if you don't believe me, let's see this in action. For example, we're going to create an empty list, and I'm going to say if not s, print hello. Okay, so as you saw, this is true, so it printed hello. So if I say if s, it's not going to print hello because this evaluates to false, and this evaluates to true. Sorry. Okay, so this is going to be true if pop stack is empty, and push stack is not empty. Okay, so if pop stack is empty and push stack is not empty, then we're going to do the following thing. We're going to say pop stack, we're going to extend it with push stack but reversed. So we're going to say reversed push stack. So now pop stack is push stack but reversed. So this allows us to call the pop method on the last element of pop stack, and that works on O1, so that will be fast. This reversed method won't be that fast, and we're going to see it later. And that's why this is the not so naive approach, because this reversed method still takes linear time, so on. We're going to see it later if you don't understand me this part now. Okay, so after that push stack, we're going to clear it, so we're going to make it empty. Now we're going to say if pop stack is not empty, then we're going to return pop stack pop. So remember, this is a list, and if we call pop, that's very fast because this is returning the last element of the stack. Okay, so else we're going to raise an index error saying that you are trying to pop an empty queue because we don't have elements in the push stack nor in the pop stack. So this is our not so naive approach. Let's test it now. So queue, we're going to pass it a list, which is going to be range of 10 million integers. Okay, so we create it, and now let's see how much it takes to append or push an element. So let's push 50, and it takes like 7 microseconds. It's very fast. Now let's pop an element, q.pop, and let's see what happens now. Okay, so it takes 113 milliseconds. It takes even more time that pop from lists. It takes here like 10 milliseconds. Here it's taking like 10 times more than that. So you may say now, but David, you were trying to pop elements faster than list. Now it takes a lot more time. Yeah, but let's test it again. Now it takes 7 microseconds. It's like faster than this, much faster than this. It's taking microseconds. Let's do it again. It takes 11 microseconds, 6 microseconds. So the first pop, it was very slow, but the subsequent calls to pop, they are really fast. So in average, this pop method is really fast. It's taking microseconds. So why is this happening? It's all because of this reversed method. So as I told you, this takes also linear time, and this only happens when pop stack is empty and this is not empty. Then this code gets executed, and this is what is making our pop method slow in the first time. But in the second time, then we are calling this code here, and this pop, it takes 01. It's very fast, and that's why the subsequent calls to pop are really fast. Okay, so that's why I call this the not so naive approach, because of course Python has its own dequeue module where you can pop elements at the beginning of the queue, and it is very fast even from the first time, and also for the rest of the times you call the pop method. But this is what we can do for now. Obviously the implementation of the queue module is much more sophisticated, and that's why it is not that slow for the first time. But we did a great job doing this. So I hope you like this video. This is a very common question you will be asked in a coding interview, and I hope you learn how to implement a queue from scratch. You can repeat this in any other programming language like Java, JavaScript, or whatever. The thing here is the logic, and the logic almost is in this part of the code. So see you in the next video.